Now in update, if we try to update some fields with a new name here that is not already present in the collection, so just by using update one and this set operator, this will not work. Here it is not modified because it does not match with the documents that are present in the collection. So for that, if we want to create a new document with update function, we can use this absurd true. Set it to true. This will look if the document is present or not, and if the document is not present in the collection, this will automatically create the document. So here we have absurd count as 1. So if we look now, we have this new name Maria in the collection. So for looking for both title and frequency in the hobbies, we want to find for sports and frequency greater than or equal to 3. If we use this, we get this result. Here sports with frequency is 2, but it still displays this because here we have the frequency of 4. This this does not mean that it has to look in a single document. It will look inside the array. If both of these conditions are met, then this will display that. So if we just want to display that particular document with both of these conditions, we can use this element match operator. We use this and put both these conditions. So it doesn't show Anna anymore, Sam anymore, because this condition now looks for in a single document. We have this. And then with this condition, if we want to use this in update function, we used it in find, and then to update with this condition, if we want to set a new field inside of the hobbies document here, so we can use this dollar sign here, hobbies dot dollar sign dot, this is the new field, and we set it uh, this, write this true. So we see it updates this here, adds a new field, high frequency true, with sports in frequency greater than or equal to 3. Now if we just find with hobbies frequency greater than 2, we get every document here because the frequency is greater than 2 in some of in one or the other inside every document. Now to use that in update menu, we write this and then we set, we want to add a new field inside hobbies. So this will add this new field to every document here. Now to look for age, the total age greater than 18. We find this, we get these 2. Then we can use this in update also. And now we have this push operator. This will add a new field inside this document. So we have this Maria. Inside that, we add this new embedded document that we give here with this push operator. And similarly, we can also use push if we want to add an array, multiple documents inside of this hobbies document. So we can use this each operator. So we create an array and put these two documents, and then we can use this sort operator to sort this in ascending or descending order of frequency. So we put them in descending order here. So if we find with name Maria, we have this entire document in descending order, not just the new ones. So we see this these two new documents are added here with this. Similarly, we have pull, which does the exact opposite of push. It removes this document from the collection. From the Maria document, it will remove this hobbies with sports field. So we have two fields here with sports, title sport. It will remove both of those. And then we have this pop operator. It just removes one of the fields which is at the bottom or at the top of the document. So if we write one here, it will remove whatever is at the bottom of the document. For example, we had Sam. We had these two hobbies, sports and cooking. So it removes the bottom, which is the cooking, by writing this hobby as one. And then for Anna, we had this yoga and skating. We put -1. It removes the first hobby from this document. We have another operator, add to set, which is similar to push, but the difference is add to set does not add duplicate duplicate fields inside of the document. For example, we had this title sports already, so this will not add another. For example, we add this first. We did not have this before, so it modifies count one and adds this here. But if we try to add it again, well, this modified count 0 and this it does not add again. Now similarly, we have delete operations. We have delete one and delete many. Delete one with name Sam. So this is deleted from the collection. And then for delete many, for example, with age greater than 25, we have deleted this Maria with age 28. Now we delete many. For total age, we have to delete. If we want to delete is 40 true, and if total age does not exist, so we can do that. So I've deleted both of these. Where total age does not, a field does not exist here, we have this. We can also delete an entire collection by using this delete many with just this empty curly braces. Now we have a new collection with persons. We download it and import by using this Mongo import. Then we open our shell, and here we have this data, contact, complete contact of a person, and all this information. It has 5,000 documents which are imported here. So we find by date of birth, age, and this is an embedded document age inside DOB with age greater than 60. We have 1222. And then in MongoDB we can use this explain. This will explain the entire process of this query. We have this, and if we write execution stats inside of this will give the statistics of how much time it is taking and how many scans it does. So MongoDB does the scans of entire collections whenever we find search something with a field, for example with a name of a person, so it will scan the entire collection. If it has 5,000, 10,000 documents, it has to scan the entire collection to look for a particular field, a particular document. So for that, it takes a lot of time. So for that we have indexes. We create indexes with other particular fields, so they will have the key value and that will have the pointers for those exact documents. So it will just search the indexes and they are sorted already, so this will save a lot of time other than if we just scan the entire collection. Here we see the execution time in milliseconds is 4 milliseconds, and the total documents examined is 5,000 for this age greater than 60. So for this, if we create an index by using this create index on this particular field age, and we put this to 1, so this index is created. This is the name of the index, and then we run this again. Initially we have this execution time way more than the previous one because this is the first time we are running this with index, so it creates some overhead. We run this again. We see the execution time is reduced to 2 milliseconds from 4 initially with the complete collection scan. And here we can see that it is scanning 1222 documents only, which are exactly the number of the person greater than 60. So it will just scan the exact amount of documents that we have to see, that we have to fetch. So here we have this index scan. So it gives the complete information about the process. Now, for example, if we try to search for age greater than 20, so we see that entire collection of 5,000 documents have age greater than 20. So here without the index, here we drop the index by using this drop index and giving the same name again. Then if we just do the collection scan, so this is the execution time. But even if we create an index for this, for gender here, no, even if we create an index for this particular thing, it will not be helpful at all, because even with indexes it will have to scan entire collection of 5,000 documents, because every person has the age greater than 20. So it will be additional time that it will take other than just collection scan. So in this case index will not be helpful, because to scan the indexes also it will take additional time. So for When we have to scan the entire collection or the majority of the documents, indexes are not helpful. Now we can use this for other fields also, for example with gender. Now this is a similar case because gender are two only, so there will be a lot of documents for both the genders. So in this case also, index will not be very helpful rather than just collection scan. So for example, we find for gender male and with execution stats, you see that it still takes a lot of time here. We will drop that index, and now we can create a compound index. We want to search for multiple fields. For example, for age and gender both, we create an index. So this will not create multiple indexes here. This will create just one index for both the fields here. So if we try to search for example, 35, age and gender male. So this will search with this. This is showing the query that it runs. We can use index, compound index like this. Then we have to search for multiple fields. Also, when we have to search for a single field, we can do this for the first field only. When we were creating the index, we put age as the first field. So this created the index name like this. So we can search for age here. This still does index scan. When the index name this age gender. We cannot do this with just the gender. If we want to find this, this is going to do the collection scan. You can see here it does collection scan, it does not do the index scan because this was not the first field that we wrote.